Hello guys, so welcome back to my channel. This is going to be the fourth video already, and yeah, this will be the first of four more consecutive videos that will discuss on past questions and of course the trial papers. So uh, hope this session is going to help a lot because these are the kind of questions that or patterns of questions that you might see in your upcoming media exam or whatever, but most importantly is your trials and your actual SPM that will come maybe next year. So this is uh, all the collection of questions regarding the three subtopics we learned in Form 4 Chapter 1.1. So now we are turning the concept that we have learned into application, which is doing the questions one by one, and also I will show like where will you earn the marks in each part of the question so that you have a better idea where is it you can score for each question based on the marks I put in the bracket like this. So first of all, first question we are doing is going to be the actual SPM paper in 2021, which also came out with functions in question number 13. So question number 13, if you know the format is under section B, which is the choice of two questions out of three. So this will be a good question to choose, of course, because you can see, you read through briefly everything. It's not that difficult of a function question. Usually, functions question won't come out that hard because there's nothing much to play with. It's quite direct and there's not much of application they can ask. But there are one or two states that came out with maybe slightly harder questions, but this is probably considered easy level for this chapter. So let's get into it. So first one, they ask this the question. So it is given that fx is 3 over 4x minus 1, where x is not equal to 1 over 4. So remember, the question will always tell this condition over here. Because if x is 1 over 4, you will get fx is 3 over 0, which causes the function to become undefined. So, and then they said fgx is 3 over 4x squared plus 3. So now, if you notice, right, if you tell me this, why they didn't put the x condition, x cannot equal to 1. So it's a very good question actually, why they didn't put this in the actual question. And maybe the reason I think is, you just try out 4x squared plus 3 is 0. 4x squared is negative 3. X squared is negative 3 over 4. So your x is a square root of a negative number. And whenever you square root negative number, you will get imaginary number. So that's why they don't want to write an x condition here, or else they'll write square root a negative number. So they don't want to show that here, because negative imaginary number is not in our level yet. So that's why they didn't write the condition at the beginning itself here. Only if it's in the form of a linear equation, they'll write the condition like this. So yeah, that's one of the parts you might be thinking. So that's basically the question already. So now when we go to the sub question, the first one is find the object of fx if the image is 1 over 3. So you have to underline the keywords here. Object, you want to find object means they want you to find x. If the image is 1 over 3 means you will assume that your fx is 1 over 3. So solution, you have to, if you can copy back this down to give you an idea where to start, but this one won't earn you marks because you're just copying any statement you copy from the question, you don't get marks because it's already given. And then you can start something like this. Given fx is 1 over 3. So you can continue your working. 1 over 3 will equal to this one, this part here. And then you just do your algebra, cross multiply, you will get x is 5 over 2. So this 5 over 2, what does it represent actually? So if you, I made a conclusion down here to tell the examiner what it is actually. Object of fx, if image is 1 over 3 is 5 over 2. So if you have an object of 5 over 2 under this particular function only, you can get an image of 1 over 3, which is the question here. So this is the first explanation for this part. So where are the marks? So this question is 2 marks. So 2 marks, first mark will come when you put this. And second mark will be your final answer over here. And then you might be noticing why I write K and N. What's the difference? So K is actually showing you your working step. So this is the marking system or something like that. N is your answer, final answer. So without having working step, your N1 won't be awarded, although the answer is correct. So that's how it works. So K1 plus N1, you get 2 marks here. So always show substitution in admaths. This is kind of like a substitution. Whenever you substitute value, you should get this K1 mark, which can apply onto the working also depending on the question. So that's A done. So that's your 2 marks. Next B, they say express M in terms of P if this condition they give you. So of course you're going to start with this condition. There's no way to express M in terms of P if this condition is not there. So you copy back, then this one, how do I get this part? So Fm plus 1. So this is X is your M plus 1. So you're going to substitute your X variable with M plus 1. And it will equal to 3 FGP. FGP is here. Means your X is P over here. Here your X is M plus 1. So there's 2 different X objects here. So after that, when you expand, you will get like this and continue here. So you want M in terms of P. So you need to be smart to arrange the equation to get in the form of M equals something something P. So from here, you can see I cross multiply here because it's a complex fraction. So you will get 36M plus 27 is 12P squared plus 9. And then you shift everywhere. You could get up to here, but don't write your final answer here because in advanced, you always want simplest form. No matter whether the question specify or not, always better to give in simplest form. This answer is not wrong, but it's not the most simplified answer. As you see here, I can factorize out 6 and then I cut with the denominator. So this is the most simplified form. Same like your certs. Let's say cert, will you leave your answer in cert 20? No, right? It will be 2 cert 5. Because cert 4 times cert 5, you get cert 20. Cert 4 is 2. So 2 cert 5, like something like this. So we always go to the simplest form. So yeah, that's your B. So quite straightforward so far. Also 2 marks only, but the working quite long compared to this one because I showed like the detail, plus minus, move here, move there, all that. But if you can work straight, then it's okay. So where you should not miss is this part. This one over here, K1. You see again, when I substitute X is M plus 1 and X is P, you see I get 1 mark. So that's why I said substitution part is very important. So then you get this, your final answer, of course, you get 1 mark. So this is in total 2 marks over here. So that's already 4 marks out of 8 marks. Yeah, total 8 marks. So next, C1, they ask you find Gx. Another direct one we have learned before in the previous video, they have Gx and Fx, they want you to find Gx. So you will copy back down, Fgx is 3 over 4x squared plus 3, and then you want to find Gx. So Gx function you substitute inside the f function here. Means your x is equal to Gx here, in this case. So you will get 3 over 4Gx minus 1 equals to the composite function here. So after you move here and there, you cross multiply, you will get Gx is x squared plus 1. This one, the 12, you bring it, you divide to the whole equation on the right hand side. So that's your answer. Gx is 2x. Gx is x squared plus 1. So where are the marks again? So first of all, only 2 marks also. So the first mark is going to when you substitute here. You see again, substitution part. Always get you 1 mark. And of course, the final answer is 1 more mark. So total 2 marks for C1. So yeah, quite direct up to C1. So C2 is where the maybe slightly higher level than these previous 3 parts. So they say hence determine whether inverse function of Gx. So this is the function Gx we got. So these 2 are interrelated. If this question somehow you found wrong, this answer might have a chance to get wrong also. So they say hence determine whether inverse function exists or not. So first of all, when you want inverse function test, you always will think of the horizontal line test. Vertical line is to determine whether it's a function or not. Horizontal is inverse function. So they say give your justification. So justification here is going to earn 1 mark, and your conclusion here is going to earn 1 mark. So how can you justify that this gx function won't have an inverse function? So one method is you can show how the graph looks like, because you know this is a quadratic graph, x squared. So you can sketch it out roughly like this. The y-intercept is 1 and the shape is smiling because a greater than 0. So when you do horizontal line on this graph, right, you'll find out, you see, it intersects at two separate points or two separate objects, x1 and x2, and they lead to the same image at here. So this is showing many to one relation, because many objects lead to one image. So if many to one, there's no inverse function. Only 1 to 1 is inverse function. That's why you realize we use horizontal line test, because horizontal line test, the focus is going to be how many objects you have. Because in horizontal line, let's say I go like this, you're only going to have one image on your y-axis, because it's a flat horizontal line like this. So on your y-axis, you can only have one image for each coordinate. But the object it projects to on the x-axis might have one or more. So that's why I always say horizontal line, it focuses on the object. But vertical line, like this, no matter how, it's going to have only one object because it's a straight line that cuts to x-axis. But if the graph has two or more points with that same object, it can have two images. So that's why vertical line, the focus will be on the image or y-axis side. So that's how you differentiate between these two tests. So I'll make a conclusion here. Since the horizontal line intersects the curve gx at two different points, it has many to one relation and not a one to one relation. So you need to specify why you say it does not have inverse function. So then you conclude it does not have inverse function because of this reason on top here. So where are the marks? So first mark will go to showing this graph, because this is a justification. And your second mark will be does not have one-to-one relation, because this is the key of the inverse function they want to see. So this is your N1 as well. Yeah. So in total, you will have 2 marks also here. So always write this conclusion for 1 more mark. So if you want to think of any other way to show a justification, maybe you can think of showing a table of values also. Let's say I put, let me think of perfect square numbers. So you can think of 4, 9, 16. So let's say I put the gx value, I assume the image is going to be 17, let's say. So 17 is x squared plus 1, 16 is x squared. So you see here, when you square root 16, you can get two objects, 4 and negative 4. So this is another proof that you can show that it might be a many to one relation also. Not only by showing a graph, you can picture this, but the most suitable method they show in the answer scheme is the graph. If you want to put this table of values also can as an extra backup to show your proof on this function. So yeah, this is total of 8 marks in your SPM paper 1 in 2021. So this is the first part. So from here, I already analyzed. So you can see from this part that this chapter is very famous to come out in paper 1 compared to paper 2. But in SPM also, the next question I'm going to discuss, it came in paper 2 as well. So sometimes the minority also wins. In this case, you cannot just base on majority from the trial papers. So only one state I think came out paper 2 function, but it came out the real SPM in the in paper 2. So that's why in advanced all chapters can be mixed randomly. There's no like definite where it's going to come. So now we'll look at the paper 2 question. Usually paper 2 it will come out in section 8, functions. In paper 1 also most likely section A. Section B got, like just now I showed, but it's quite rare. So now let's see the next section. So they said This is question number 3. Let's say diagram 1 shows the relation of 3 sets. So they gave something like an arrow diagram here, 3 boxes. So it's labeled as set P, set Q, and set R. So set P they put X, set Q is X plus 2, set R is 3X minus 4. So F maps set P to set Q, and G maps set Q to set R. So from here you can already come out with various information. So what are the info you can write down directly from looking at this question? Fx is X plus 2, and Gfx is 3X minus 4. Don't say Gx is 3X minus 4. We have to find out Gx because this result here is the result of 2 composite functions. That's why Gfx is 3X minus 4. So after you interpret this, then you read the question what they say. They say find part A, Gx. So again, the basic method we used just now, how to find Gx from a composite function. Only thing that one they told you Gfx is what, but here you have to interpret the diagram, then only you know this. Then you proceed with the same step. So there's an extra 1 step involved here. So Gx, they say 3 marks. Okay, so how do we do it? Divide it like this. So we'll start with the info that Gfx is 3x minus 4. So we have our fx, x plus 2 equals to 3x minus 4. So you will make an assumption that y is x plus 2. So you find x is y minus 2. So then you will substitute that x plus 2 with y equals 3 y minus 2 minus 4. So you'll get 3y minus 6 minus 4, 3y minus 10. So this is your gy. So you want to substitute back that y with x because the question asks gx. So you write there, substitute y with x, and gx will equal to 3x minus 10. Done. See, 3 marks for just this working. So it's very good, very beneficial. So first mark will go to when you substitute your fx function. You see again the trend. Whenever you substitute, you get 1 mark. And then the next mark is when you do this assumption. And again, you see you substitute your x equals y minus 2 into the x here. So you see another 1 mark. And of course, final answer 1 mark. You see, even if you made a careless mistake along the way here, you still already get 2 marks out of 3. If let's say this final answer is wrong, that's why working is important. It can add up to a lot of marks actually. If you have your final answer wrong, also it's still okay. So next, B1. So B1 they asked to find f square x. So f square x, we already have fx here, so we just double it up. So this part is 2 marks also, quite short. So we know that fx equals x plus 2. So f square x is f bracket fx. So always continue the same function on your left hand side. So it gives a smooth flow. So you substitute inside that, and you sub x plus 2 as your x under the f function. You'll get x plus 2. Remember plus 2 at the back also, because x only is x plus 2. You still got a plus 2 at the back. So f square x is x plus 4. Done. See? Very fast can solve if you know the technique. So first k1 is coming here. Because you substitute, you see again, into another function, f squared. So that's applying your knowledge of composite functions. So that's why you earn a mark there. And your final answer 1 mark, total 2 marks. So that's your B1. And part B2, this is quite interesting. B2 is slightly higher level than the other 2 parts. So they ask you to find the function f and x in terms of n and x. Also 2 marks. So how are we going to do this? You see, suddenly they give you a random term here, f power nx. So you must think in the form of, they want you to create a general equation that can represent the pattern that's going on from B1. This one is not related to A1 exactly. I mean part A exactly. It's from B1. After you deduce this, you can already see a pattern from x plus 2 to x plus 4. So how do I confirm this pattern is I find f cubed x. After doing 3 times, you can be more confident that there's a pattern happening. How we find f cubed x is actually f times f square x. This is the idea we come out with. So you will get f cubed x is f. What is your f square x? You already found here. So you just sub inside x plus 4. And then f cubed x, you'll sub x plus 4 under this function f. So you'll get x plus 4 plus 2. So you f cubed x will be x plus 6. So you see a pattern here. Plus 2 plus 4 plus 6. So that's what they want you to conclude from here. So I can say therefore fn x can equal to x plus 2n. And I will say I'll put an extra one at the back here where n equals 1, 2, 3, dot, dot, dot. So when you substitute n is 1, you will get x plus 2, which is your fx. So n power 1, f power 1 is fx. No? If f power 2, you will get x plus 4, which is this one. If I put 3, f power 3, you will get x plus 6, which is this one. You see the pattern recurring. So that's how you get your 2 marks. So after you find your f cubed x, you get 1 mark. And conclusion, 1 mark, 2 marks. So don't forget to find your f cubed x before you make this conclusion directly. So make sure you have an extra working here as well. So total here is 7 marks. This one is SPM paper 221. So you see it's quite smooth flowing, quite easy to solve. Because all the questions are direct, there's no application here. One more thing I forgot, this one here. The one I put in the bracket is the one that's necessary to give you the mark. If you want to add this, it's okay, just to show what you're meaning, but this is the requirement to get the 1 mark only. So that's all. So yeah, that's one more question done already. So that's the whole SPM of 2021 involving functions from this chapter. So next now we are going to all the states already that came out with functions. Okay, so first state we are going through is Johor paper 121. So functions came out here in paper 1 also, so you see the trend. So the question is, first question itself. Okay, so this is the question, so you can scan through for a while. So now part A comes. Determine the value of A and B. So directly when you see the first part, right, they already ask you 2 variables, means the thing that should strike your mind is you're going to be involving something about simultaneous equation because you have 2 unknowns. simultaneous equation in two variables. So we're going to construct two equations and find out the A and B values. So that's why you can see here, they gave you two info here. Two pairs of object and image. So that's how you can form the function based on this general formula they gave you here. So you can find your gx and x based on this, and A and B is your question. So that's part one. Part one will give you 2 marks also. And part B, quite a famous question also. Find an object which is mapped to itself under function g. This we discussed also before in the second video, I think, I'm not sure, yeah. So these are the 2 marks. So total 4 marks for this question. So part A. So how we're going to do? So first we see image of -3 is -21. So don't say -3 is directly your image. Image of -3 is -21. Means -3 is your object, -21 is your image. And here again, object of 4 is 2, means the object is 2, but 4 is the image. So don't put it in the wrong area in the equation. So gx is ax minus b. And then you can put something like when x is -3, gx is -21. So this is your step to show which information you're dealing with first. So -21 is a -3 minus b. So you solve. So usually when you see all negative in front, you will turn the whole equation to positive. We just times the whole equation by negative. And I will express b in terms of a. Because I know I can substitute b into the second equation I will form here later on. If I want to express a in terms of b also can, but you will realize you will get a fraction which you don't want because it's 3 in front here. So you'll get a fraction. So we'll proceed to the next one because I cannot continue anything here already. So when x is 2, gx is 4. So 4 will equal to a2 minus b. 4 is 2a minus b. So you see I label this as 2. And from here I can write substitute 1 into 2 because there's a b term here, single b term. So what I will get is 4 equals 2a minus, make sure to bracket because negative and negative is positive here. So 4 is equal to 2a minus 21 plus 3a. So you shift 21 to the other side, 25 equals 5a. So your a is 5, see? You already found one unknown already. So then how to find back b is you put this a inside here. So what you will get is, you can write substitute a equals 5 into 1. So b is 21 minus 3, 5. So b will be 6. Done. The first question you already addressed. So in this case, right, only 2 marks. So where it's going to come from is, the first mark is when you show your substitution over here, this part. See, again, substitution earns you always a mark. So this part is the tricky part. So although you have 2 answers, you won't get 2 separate marks. They both apply to the same mark. So in this case, you need to ensure both your A and B pairings are correct to get 1 mark. If you get either one wrong, most likely you're only going to get 1 mark because maximum is 2 only. So yeah, so be careful with finding your variables. Usually if one correct, the other one is correct already. So that's why they gave you as 1 mark, unless you careless along the way here. So yeah, that's 2 marks. So part B is a very short one. Part B is find the object. So now you already found A and B value, right? So don't forget, update your equation on top here. So gx equals A is 5, x minus 6. So from here, you'll make a condition. Let gx equals x. This is the key of the solution. because you want to find an object x that can give you a same image value of gx. So from here, you'll substitute this gx with x. So you'll get x equals 5x minus 6. And then you shift the x to the other side, negative 4x minus negative 6 equals negative 6. This one you put here. So x is 6 over 4. So don't stop here, simplify. You'll get 3 over 2 done. See, so simple for 2 marks. So where are the 2 marks is, you do this one here, means you show you understand what you're doing, K1, and then N1, final answer, 2 marks. So total in this question, you get 4 marks. So yeah, this is the first question for Johor. So this one, functions also followed up in the second question actually, in the same state as well. So let's see this one. This one slightly higher level than this. So later on, if you want to see where the marks are allocated nicely, I will actually post the PDF for the answer scheme under the comment section so you can see better where your marks are coming from. So now still Johor paper 1 in 2021. So this question 2. And also, we want to have more time to read through the questions. I can also put the PDF there in the comment section. Because here, after I write down, I'm directly solving already. This is on inverse function subtopic, the latest video I did. Okay, so this is the question. So there's 3 parts to it. But all in all, it's only 3 marks. So each part is only 1 mark. So in 1 mark, it's most likely you're just going to state the answer only because there's only an N1 mark there. There's no working step to show. So this is more like a test of your inverse function. So each one is 1 mark. Okay, so part A. So read the question first. Diagram 2 shows the graph gx is square root 4x minus 3. So this is a normal function, and this is the domain that you have to that respects to the graph. So they say graph hx is the image of gx. You see another graph coming into play here. Under the reflection, this part is the condition of inverse function to the normal function. In the reflection of line gx is x. So they actually provided you a diagram here, so you can see a better picture. So it looks like this. So this is your gx is x. Or in normal terms, we call it y equals x, the line that cuts to exactly to the origin like this. So this is your x-axis. Why they say gx is because they don't label y here on the y-axis. They use gx instead, since we are dealing with functions. So one graph, it comes like this. And this is the gx is square root 4x minus 3. And your hx graph goes like this. So can you see there's a reflection happening here? And then they say for this domain, so you can actually put the values already. This is 3 over 4. And this approximately is 3. Because this whole function domain where it stretches up to is covering this range of domain, 3 over 4 to 3. And then, so how I'm going to label on the hx graph is another condition. The domain of the normal function will become the range of the inverse function. That's one condition I shared in the previous video of inverse function. So this would be a 3 over 4. This is 3. And does it make sense? You see, I try to extrapolate this graph. You will get that. see this line will intersect 3, 3, these two coordinates. And you know that in line y equals x, x is 3, y is 3, based on the function here. You see, everything makes sense. Why I said it's like this. So yeah, so this is how it looks like. So now we are going to find out what's the function hx. So how to do it is we just inverse this function, since it's just opposite to each other. So we know that gx is square root 4x minus 3. So we're going to make a condition here. Hx, you can say that, hx is g inverse x, which equals to y. So this is the condition. So when you shift x will equal to gy, you bring the g this side. So you get x is square root, you substitute the x with y, you get this. So now we want to find y in terms of x. So how we're going to do it is square both sides, because you don't want the square root is disturbing your equation. So when you square both sides, you remove the square root, x squared. So then you shift the 3, x cubed plus 3 is 4y, and your y is x cubed, s squared plus 3 over 4. So you can conclude that g negative 1x, which is your hx, is x cubed, x squared plus 3 over 4. And it makes sense also. Why? Because you see, it looks like a quadratic shape. They didn't show you this part that's happening on the left-hand side, but this part is part of a quadratic equation. So you can test whether this is correct also. So this is your answer. So again, so definitely only 1 mark here, because the question is only 1 mark. So your final answer is your mark. And then now part B, they say the domain of function h. So this function. So if you want to find domain of function h, you must think in the sense that it will be the range of the function gx, because they are inverse to each other. So part B, I'll have this first. So now you have to find the range of this function to know the domain of this function. So how to find range is we just use the given domain here for this function and we substitute inside. So we know at x equals 3 over 4, your hx, and not hx, this function gx. Gx is 0. And you want to test again. At x is 3, what will you get? So we will put that g3 equals to square root 3 minus 3. So it's square root 9. So you'll get an answer of 3 or negative 3 here based on the square root. So which one you're going to take is depending on where it's located, this graph. So you see here, right, if I project this here, it's on the positive side of the y-axis. So that's why I'm going to take, okay, wait, this one is x is 3. Yeah, correct. It's on the positive side of the y-axis. So I will take x is 3 and reject this one. So you like since x more than 0, that's why x is 3. So from here, I can already make a conclusion. So the domain of the h function will be 0 less than or equal to x less than or equal to 3. And it makes sense. The h function is here. So this will be your domain. This is the range on top here. So yeah, this is the thing, 0 to 3. So it's based on the range of this function. So that's how you find the domain. So this is the answer. So directly from here, you get N1, 1 mark only. So that's your part B. And then part C is a good question also actually. So part C, they ask you GH bracket P plus P over 2. That is the most simplest question in the world. You just have to copy back the object P over 2, done. And how I get this understanding is G and H are inverse to each other, you must remember. So G and H will automatically cancel out each other and get the object back, which is P over 2. Same with this concept. GHX equals HGX equals to X. when we try to verify the inverse function, whether it exists or not, you will get back x, which is the object. Or you can also put g is h negative 1, right? You can try out h negative 1 h p over 2, you should get p over 2 also. Because h power negative 1 times h power 1, you get h power 0, which is 1. And then 1 times p over 2, you also get p over 2. See? Many methods you can use to prove the same answer. So yeah, so I will show it. So you also get 1 mark for this only, your final answer. So total this question only 3 marks, besides in paper 1. Paper 1 usually is quite short and fast questions. So this one also paper 1. But this one they add on to a daily life situation. So now it's more like relatable to daily life, the question. So now we're going to different state paper again. So this one is MPSM Kedah. So Kedah also came out in paper 1 in year 2021. So the question is also the first question it came out in paper 1. So the situation they gave you is about selling and profit price. So here we are only talking all the info is per day. So we don't want to confuse with months and years. So to avoid the times 12 and equation like that. So this one has 7 marks in total. So they give you the first question, which is 1 mark only. They ask you to create the function that represents this whole situation. Okay, so this is the first question. So they said if F represents the profit of the food packet delivery service, to express F in terms of N. So they said Daniel is okay. So the cost price of each food packet is RM 570. So there's 2 prices involved here, cost price and also selling price. So the profit is going to come from the selling price minus the cost price, of course. Cost price is your production cost and selling price is the one you sell to the customers. So quick maths, you get the profit is 0.80 here. And on average, he spends 24 on the petrol. So this one is going to be deducted from your profit, of course, because you're going to spend that one out. And why they put the variable N here is because N will represent how many times you go and deliver the food packet, of course. So how you're going to write this one is, you can first show how you find the profit. So profit will equal to RM 650 minus RM 570, which is RM 080. So this is talking per packet. And then they already gave you the condition. 1 packet is RM 080. So N number of packets will get you RM 080 times N. So this is the ratio concept we use here. And then they already told you that he spends 24 on the delivery. So therefore your function will be Fn will equal to 0.8n minus 24. Done. Just 1 mark only. So all these actually unnecessary, but it gives you the idea to this function, of course. So that's the 1 mark over here. And 1. So part 2 is upgraded a bit, 2 marks. Okay, so this question a bit not clear actually, if you ask me. The English version is not clear. So they say find the value of n to break even. So what you might be thinking, what is break even? What they're asking you here actually. So break even actually means profit is equal to the cost. So it's quite a tough term to understand what you're going to find here. So you have to know that profit is cost. So profit is your 0.8n based on this n number of packets, and your cost is 24. So they want to find a condition where both of these are in equilibrium. So how can you do that is make your profit also equals to 24. So you can say 0.8n is 24 and n is 24 over 0.8. So your n you will get as 30. Very fast actually, done with it. 2 marks. So this comes from the condition actually you let your Fn is 0. Means the profit minus the cost you should get 0 if both of them are equal to each other. So 0.8n minus 24 is 0, same thing also. So you'll get n is 30 as well. So 2 marks. So one of the mark is you show this one. Another mark is your final answer. So 2 marks as well. So that's 3 marks already. The next part is the one that's more applicable, which is the graph sketching. This one is not related to this whole question, so I cannot already. It's a separate section. So part B. So they say given that fx is 3x minus 5 and hx is 2 minus 2x. And they ask you to sketch the graph of modulus y equals hfx. So here you see they're testing you 2 things. Do you understand how to do modulus function, and can you find the composite function in the first place? So they gave you a domain, of course, then you know how big is your graph size for 0 less than x less than 3. And then they said hence state the range of y. So after you draw the graph, you can find out the range or the codomain. So now first question is you have to find the composite function, then only we can draw the graph. So you want to find hfx. So hfx is h bracket fx. So you sub your fx function is 3x minus 5. And 3x minus 5 will become the object that is met under the f function. Under the h function. So you'll get 2 minus 2 bracket 3x minus 5. So from here you expand. So 2 minus 6x plus 10. So you simplify. 12 minus 6x. Of course, it's in a modulus when it's in this function form. Because the question asks for modulus 12 minus 6x. So you do this, you already get a mark because you find out composite function. So from here, we are going to do a table of values that can aid us to draw the graph. So what value I'm going to put randomly to the x coordinate to find the y coordinate. So that's why they gave you this range here as a guidance. So you can put 0 and 3 because that's how far it stretches. 1 and 2 doesn't matter because the graph will eventually connect these 2 points that pass through the 1 and 2 coordinate. So one more assumption I can make is let y is 0 as well to find out where it intersects on the x-axis. So 3 columns is enough already actually. If you want, you can try also for number x is 3 also if you want, just to satisfy the range. So when x is 0, you will get You don't need to show working for this actually, because it's not involved in the mark. It's only the graph that gives you the mark. So when x is 0, you get y is 12. So modulus positive number, you still get the value of it. If 3, this is when the case comes. So 12 minus 60, 12 minus 18, you get modulus negative 6. Modulus negative 6, you only take the positive 6. Okay? So if 0, you'll look like this. So you will break the modulus, you still get 0. Of course, positive or negative 0 does not matter. So you will get x is only one value, 2. And this one, when x is 1, you should get 12 minus 6 is 6 also. So you see two common images here, means it's showing a many to one relation. So you can conclude that this is a function but won't have an inverse function, you see. Because of this modulus effect, it has caused this function to not have an inverse function already. So now it's the graph sketching. So make sure it's tidy and nice. So how the graph will look is, this one no need graph paper, it's just a random sketch only. So all on the positive region. This total 4 marks. So you put 0 and then make sure the distances are equal, try your best. So here is 1. Here is 2. And then here is 3. So you only need to do up till 3 because your range for x is 3. But for this one, we can estimate. You don't need to do one by one like this. Just put randomly your halfway point of this graph. You can see somewhere 6 here and 12 is up here. So 0, 12, you plot x here mark. 3, 6, you can try to do these dotted lines if you want to be precise. So your intersection is here. 2, 0, you mark on the x-axis. 1, 6 also is here. So you see, you can see a shape coming out from here. So make sure you don't draw a curve to join all these points. It's not a curve graph. Because you see the equation is linear equation. So you draw a curve, you're going to lose 1 mark for the shape. So make sure you use a ruler to connect these dots, not a freehand. So it's down like this, up like this. So done. That's your graph already. So you've completed this part. So you say hence take the range of y. So you can see from here, range of y is 0 to 12. Done. So that's how you get 4 marks. So first mark is when you find your composite function. So 2 marks are coming from your graph. So first mark they want to see is your V-shaped graph. So if you see a V shape, then you get 1 mark. And then another thing they want to see is all your points plotted correctly. Points 0, 12, 2, 0, and 3, 6 are seen. So that's why you get your K1 as well. And your N1, 1 more mark where? This one 4 marks, right? This part. Hence take the range of Y. So range of Y, you show this correct, 1 mark also. So total 4. Done. So Kedah paper, we already solved 7 marks question. So this is under set 1 actually. There are 2 sets to this paper. So set 1 paper, it came out this question. So there's no more graph sketching here, I think, yeah. All is normal functions now. So this is the third last already. So Kedah set 2 now. Also in paper 1, it came in the first question. Okay, so part 1, they ask you, find the value of n So you might think here there's two variables in the denominator. How are you going to find n actually? So you must also be alert of the condition they gave you here. X cannot be 1 over 3. So you're going to start that condition to find the value of n. So you'll write something like this. Let 3x minus n is 0 when x is 1 over 3. 1 over 3 minus n is 0. 1 minus n is 0. Negative n is negative 1. N is 1. Done. Means with this value of n and this value of x equals 1 over 3, you will get an undefined function, in other words. So only 1 mark. So 1 mark will come from your correct value of n, of course. So part 2 now. Part 2, they gave you an equation and ask you to find a value. Two marks for this. So it looks complex, right? This kind of equation, but actually no, it's just about the function here only. So make sure you update your value of n. So you will get fx is m over 3x minus 1. So from here you can proceed already. So they said find the value of m2. Okay, find the value of m, not m2. This is 2 marks. So how you're going to do it is you start with this equation, of course. So 3 times f power negative 1, ignore the 3. 3 is just multiplying this function by 3 times. So f negative 1, you sub your x is negative 1, you will get m over 3 negative 1 minus 1. Make sure you show all this. This is where the mark is coming from, the steps. And when x is 1, you will get m over 3, 1 minus 1. And this whole thing is equal to negative 1. So from here is your basic algebra to solve. No? 3m over negative 4 plus m over 2 is negative 1. So you could shift the negative to the top for the fraction. And how to make it equal is you can do a method like this if you want, error-free. So you will make the whole denominator as 4. So you will get negative 3m plus 2m is negative 1. So negative m is negative 4, m is 4. Done. Found your m already. So that's how you get your 2 marks. So first mark is you show this one. This part very important. And your second mark, of course, your answer. So 2 marks in total. So that's your 3 marks already. So part B is the longer one with 4 marks for this part. Is it related? Not related. Another simultaneous equation example they give you here. So you see it's quite famous also. In this chapter, they always test you back on your basic in lower form. So part B. So they give you 2 functions. Whenever they give you 2 functions with 2 unknowns, you already know something is happening on the simultaneous already. Very clear pattern. So they'll give you conditions, of course. Here you have to apply inverse function also to solve. This is a good combination of all the knowledge you've learned together with composite. Total 4 marks. Okay, so how we're going to solve this is, first of all, we start with the info, or you want to find the G inverse, because you see an equation involving G inverse, right? And you have the GX. So you'll copy it down there. GX is PX plus 2Q. And you'll make the same condition, that G inverse X equals Y. So from there you proceed. X is GY. you substitute your x with y, and you want to get y in terms of everything else. So py is x minus 2q, y is x minus 2q over p. And you conclude that g inverse x equals x minus 2q over p. You see, you found one side already. And you can already solve this equation already, this whole part. And then the second part, of course, you have to find composite of gk inverse. So you need to find k inverse also, apparently. So kx, x plus 2. Again, same thing, let k inverse x is y, x is ky, x is y plus 2, y is x minus 2. Therefore, k inverse x is x minus 2. Then done already, found both inverse. So now we do the equation. So g negative 1, 2 is k negative 1. So what's your g negative 1 is here already. So you just substitute your x with 2. You'll get 2 minus 2q over p. K negative 1, we use this function direct. So you will get negative 1 plus 2. So 2 minus 2q over p is 1. P is 2 minus 2q. I let this be my equation 1. Then I can substitute it somewhere else. So next info is gk inverse 4 is 5. So your k inverse is x minus 2. So you put g bracket 4 minus 2. Because you can already substitute your k inverse x as 4. So you will get 4 minus 2, which is this one. So you'll get g2 is 5. And you have your g function already here. So you say an x is 2, you will get p2 plus 2q is 5. So 2p plus 2q is 5. So this is your equation 2. And you write sub 1 in 2. So you will get 2 bracket 2 bracket p is 2 minus 2q plus 2q is 5. So 4 minus 4q plus 2q is 5. Negative 2q is 1. Q is negative half. One part solved already for q. So let me check. Q negative half. That's my q. Yeah, correct. So then you want to find p. Sub q is negative half into 1. Because you see 1 is already expressed p equals something. So you can find direct, no need to do long working. 2 negative half. So p you will get 2 plus 2 over 2, which is 3. Done. So where are the 4 marks coming from? So the first mark you will get is from copying or from finding the inverse function, this one. This is your k1. Or your another k1 can be from forming this equation. So that's another mark as well. And getting your correct q value n1 and also your p value n1. So that's your 4 marks over here. And also getting this one, this first equation is also another k1. So you see there's 2 options here, they can give you the mark. So they'll choose either one. And the advantage of this question is, let's say you get either p or q value wrong, you still get 1 mark. You won't get like no marks for the whole thing because the total mark is 4. So 2 separate answers, 2 separate marks, and the working gives you 2 marks. So in a way, it's an advantage for this question. You can score a higher amount of marks. The total is 4. So that's done for Kedavadi. So second last one now. It's about Kelantan. So Kelantan functions came out in paper 1 and paper 2 as well. So let's see how they structured the questions here. Yeah. Kelantan, the first one in paper 1 is quite easier compared to the paper 2. So this came out as question number 2 in paper 1. So again, very direct question, no twist and turns. So they said they gave you a function. Given function g inverse fx. You see, they start complex, this question. So first part, they ask you to find the function gx. And the next part, they ask you to find, this is 3 marks. Part B is, never mind, we do part A first. So first one is, we have to use the info here, of course. So from here, you can see that we can find function g inverse, and from there, we can find function g. So that's one way of thinking. Yeah, that's quite a fast-forward way to think. So g inverse fx is 2x minus 1 over x. So now you're going to substitute your fx here. So g inverse 3x minus 6 over x plus 2. Make sure you're aware of the amendment here. In the trial, they actually told at this part in the actual paper, they put x minus 2, but it's actually x plus 2. So make sure you're aware of that amendment. So from here, you're going to let, same step again, y is 3x minus 6 over x plus 2. So you express x in terms of y. So you shift this x here. And then you want to factorize y, factorize x, because you want x in terms of y. So you will get x equals 2y plus 6 over 3 minus y. If you want, you can write the condition y cannot be 3, just as an extra. So from here, you will get g inverse y is 2y plus 6. Oh wait, no need, you can substitute inside the x already. So you know x is this one, right? So you can put it inside the x variable here. So you'll get g inverse y is 2. So it's going to get a bit complex here, but bear with me. 3 minus y minus 1. So you see a lot of fraction coming into one equation, but solve it slowly, you will eventually get to the answer. So g inverse y. So from here, you have to expand this fraction. So you will get 4y plus 12 over 3 minus y minus 1 over 2y plus 6 over 3 minus y. So just continue solving. So make sure you make the same denominator for the numerator on top here. So you will get 4y plus 12 minus 3 minus y. So make sure bracket here, or else you'll very wasted. Over 2y plus 6 over 3 minus y. So g inverse y will equal to, so you expand the bracket, you will get 5y minus 9 over 3 minus y. So this you shift, means you inverse the fraction. So you will get times 3 minus y over 2y plus 6. So you proceed here, you will get g inverse y is, you can cut this off, 5y minus 9 over 2y plus 6. So you can say sub y with x to make sure it looks more natural. 5x minus 9 over 2x plus 6. You can put the condition again. X cannot be negative 3. So after you get this, you want to find gx. So now you have the inverse process. Usually we find inverse function from normal function, but now you have the inverse function and you want to find back the normal function. So how you do is, you have to just reverse the whole process basically. So you will get Gx is equal to, okay. This one we have always an assumption that let G inverse X is Y, right? So you can substitute this G inverse X with Y. So Y is 5x minus 9 over 2x plus 6. So you express X in terms of Y, you should get the answer already. So 5x minus 9 is 2xy plus 6y. So 5x minus 2xy is 6y plus 9. We factorize the x, shift the y over there, and that's your answer actually. So you can put the condition again. In this case, when you write back gx, right, make sure you substitute the y with x again. So there's a lot of substitution going on, so be careful. With the condition that x cannot be 5 over 2. So that's your answer done. Very long working, but you will eventually get there. So that's the answer for this one. X, 5x minus 2x, okay. Yeah, that's the answer. So where the marks are coming from is, first mark you will get when you find out G inverse Y, this part. When you sub inside, you see again substitution earns you a mark always. And then second mark, this part, G inverse X. You can find this. And the third mark is of course your final answer. So yeah, these are 3 marks in total. So part B, much more simple, because this already gave you a long section. So part B is just about playing with whether you know how to form the function with the object and image. So part B, they ask you, find the value of P if GP is 2. So you're going to start with this, of course, GP is 2. And I think this one also got amendment. They put GP is 12 in the, somewhere I think, in the answer scheme. So the answer scheme has an amendment there. So GP is actually 2. So then you say GP, we already found function G earlier, right? We found that Gx is 6x minus 9 over 5 minus 2x. So from there, you will assume x is P. So GP equals 6P minus 9 over 5 minus 2P. And this whole thing is equal to 2. So when you shift here and there, you will find your P. Make sure you cross multiply as well. 10P is 19, P is 19 over 10. Done. That's your answer. 2 marks only, this one. So it's quite short. So again, when you show your substitution here, 1 mark. And when you get your final answer, another 1 mark. So 2 marks in total. So that's your paper 1 for Kelantan. And now is the last one for paper 2. Quite an interesting one. This one, this I would say is the hardest for today, I would say. That's why I put it last there. So done more on graph sketching actually, and how you understand inverse function and all that. So Kelantan MPSM paper 2. So part A is also 3 marks. This one they ask you to sketch the graph. About the same like what we did just now. Modulus graph also. So you see it's a very popular thing they test in this chapter, modulus graph. So again, you see they specify to you the domain so that it's easier for you. And they ask you to find the range. You see the pattern is always similar. 3 marks. So first is sketch the graph. So this one we don't need to find composite function, all that. Directly we plot the table of values. One more thing here is negative modulus. So that's an extra thing here. So be careful with the negative and positive here. The table of values. So you're going to use this domain again, negative 2 and pi, of course, as your x values. And you'll assume one section when x is 0 and one fx is 0. So 0, 0, negative 2 and pi. So from here we can plot the graph. See, 4 points should be enough to show you the shape of the graph. Usually it's 4 points. So when x is 0, you should get, this one must be careful. So it's negative 5. So when you modulus, you still get negative 5. Because when you modulus negative 5, you get 5, and there's a negative out there already. So you get still negative 5. And then when it's fx is 0, you still will be normal, I think. Let me see. So when you modulus it, you will get mixture bracket. This is the catch here. So when you take out the modulus, you still have a negative outside there. So this whole equation automatically comes under bracket. You see the value will change. So x is 5 over 2. So be careful. And then when x is negative 2, you will get modulus of negative. Outside here also got negative. So negative 9. So you'll get negative 9 also actually. Same like here. So the negative part is not affected by this modulus graph because they already added intentionally a negative outside it. So if positive 5, you will still get negative 5 also. So you see, again, the same relation. Same image, different object. Many to one, is one to many to one relation. Yeah. So this graph is a function, but it won't have an inverse function. Although it's in the form of a linear equation, because of the effect of the negative outside the modulus, it causes it to not have the inverse function already. So when you plot it, you will get something like this. So this one, make sure your graph, you prepare a negative region for it because it has negative value. I'll put it up here. X, fx, and 0. So this one you don't need to be so particular with the scale and all that, but just have to make sure it's reasonable for both sides. So pi over 2, here's 5, here will be pi over 2, negative 5, negative 9. Okay. So now from here we can plot 0, negative 5 here, pi over 2, 0 here, negative 2, negative 9. If one, you can do this dotted line here, and pi and negative 5 is here. So you see the shape? You can form a V shape again, like an inverted Nike tick. It's a very common graph you will see in this chapter. So that's how you draw it. It says sketch a graph and specify the range. So it says range is this part. You see the graph covers the longest part is from the 0 to the negative 9. So make sure when you write your function here in the middle, you put as fx. Because the y-axis is fx. Don't put y because this function is talking about fx. So that's how you solve for this question. So how you get the marks? Of course, your final answer is the 1 mark here and 2 marks from the graph. So first N1 modulus graph, they will check whether you have drawn the correct shape, which in turn means the V shape they want to see. And then another mark is your points again. You see? So always check your point. So you have to plot your 3 points they want to see is negative 2, negative 9, and pi over 2, 0, and pi negative 5. So these 3 points plotted correctly, without the other 1 point, they are still accept you for this mark. So total is 3 marks for this part. And now we will enter already the last part for Kelantan. So we'll conclude it with this one. So this one is about inverse function. Part B. The function f(x) is 2x plus 3 over x plus 2. So they give you the domain again, you see. So whenever they gave you a domain for normal function, you should already think that this is the range for the inverse function. That's the concept. Okay, so this one also gives you 3 marks. So the graph shape looks like this. So you have the negative region and the positive region. Negative 1 over 5 and 2. Usually this kind of graphs, you see, they'll have the curve shape like that. And then this graph function is y is 2x plus 3 over x plus 2. Okay, so from here, they said that it is given that f negative 1 exists. Let's say I never tell you this statement, you should also know. You can already prove it. You can use your horizontal line test. You see it intersects only 1 point. So 1 point means it has the inverse function law, of course. So now the question comes on the same plane. So don't draw separate diagram. Use the diagram given. Sketch f inverse and hence find domain and range for f inverse. So this also is 3 marks. So how we solve this? First we must sketch the graph. So what I said earlier, the domain for this function is the range for this function. So the range means it's on the y-axis. So negative 1.5 will come here and 2 will come here. And you realize you have to reflect on y equals x for inverse function. So this is your y equals x. And your graph will be 0, negative 1.5, and it will come up to 2, 2. So it will look something like this. You can see, both are reflected with each other and they meet at the same point 2, 2. So yeah, that's how you do it. So you can label also f inverse. You don't need to find the function, but just label it as f inverse. You only get 1 mark. And then they state the domain and range for f inverse. So f inverse domain will become the range of this graph. So you need to find the range of this f normal graph. So we already have 0 here, but what is this point? How do we know? It's the y-intercept. So we can say that x equals 0 and we find out the y. So you will get that y is 3 over 2. So the point here is 3 over 2. Yeah, so that should be your answer. So domain will be 0 less than x less than 3 over 2. So the domain for this f inverse graph makes sense also. You see here is 3 over 2. So you can find out from there. So yeah, this is how we do this question. And then range, they ask you, range of the inverse graph will be the domain for the normal graph. So basically, you just copy back this statement. They already gave you the answer on top here. So your mind must think inverse. So range, we use y. Because the graph, they gave you y, or you can also use f inverse x if you want. So you're writing the range for the inverse function specifically. But for domain, you can use x. You don't write f inverse x because this is the image. So yeah. So where are the marks? First one is when you can draw the correct shape of the graph. And the 2 marks is when you state your domain and range correctly. The total is 3 marks. So the whole question gives you 6 marks. So yeah, that's your discussion for part one. So hope the discussion helped a lot for, I think we did around 7 questions already. So continue staying in tune for more discussion on part one and part two videos and part four as well. So thank you.